of our production there as well. Up in Los Gatos, we have a lot of obviously engineers who support and develop out the product itself, among many, many other things behind the scenes. Just to level set where Netflix is at today, I think last quarter we hit 90 million members globally. We've launched worldwide, everywhere except a few countries, including China and North Korea, as you might guess. We support of order 1,000 device types. Our users log 3 billion hours per month. We log about 100 billion events per day, which supports quite a bit of data science efforts. And Netflix, as you probably know, represents more than 1/3 of peak US downstream internet traffic, larger than any other single source. So that's a lot of viewing. I actually went to Berkeley. I was here 20 years ago. I started in 1998 as an undergrad here. Lived in Clark Kerr, for those of you who are familiar with Berkeley. And I initially studied music. So I was just down here in Morrison. I hated musicology, so I dropped out of school. Played music full time. Came back to study physics, obviously. So I studied down here in Campbell and LeConte. So I'm very familiar with this area. My area of study was dark energy, dark matter, and gravitational lensing, which you may not think lends itself to Hollywood data science. But the skills of a data scientist are highly fungible across industries. I'm sure you've already figured that out by now. So a lot of the skills I learned in my undergrad and PhD studies are highly transferable to artificial intelligence. So that's my background. Right around the time that I started, the Netflix DVD subscription service was beginning. Did anyone subscribe to the DVD service, say, in the early 2000s? Early adopters? That's pretty good. Took me a long time. I started in, I think, 2005, 2006. The streaming service started with a bang in 2007. You may remember QuickFlix, I think it was called, which was a PR disaster, which I feel actually Reed Hastings and team handled very, very well. So that's when Netflix started streaming video and separated out the streaming service from the DVD business. The DVD business still exists today. Some of you may still subscribe. You can get Blu-ray and DVD. It's shrinking, but it's still pretty robust and I believe profitable. In 2012, Netflix adds a studio. So what does that mean? That means that Netflix starts producing content. It's a very fuzzy definition of what it means to produce content. You can acquire the rights to brand on existing content that someone else produces. You can produce from scratch. So depending on how you defined it, our studio operations ramped up between somewhere around 2012 and probably 2015. And it was a slow ramp up. And then last year at Consumer Electronics in Las Vegas, we went global. So at that moment, Reed Hastings, I don't know if you saw this talk, he says we're launching globally, and we launched globally at that moment. All that meant really was that our local Netflix website allowed people to pay for the service in each country. And that's still the case today. So the DVD service was very healthy for a long time. And the DVD service was enabled by the DVD format, I would argue, which is to say that DVDs are very amenable to mail rentals. By the same token, bandwidth of the internet around 2007 hit a point that supported streaming on typical devices like computers, laptop computers. So that's when Netflix with great foresight, immediately launched its streaming service and started making streaming SVOD deals. So SVOD stands for streaming video on demand, and that's the kind of business that Netflix streaming is. Just to give you a sense of how engaged people are with the Netflix streaming service, we studied, a data scientist on my team now, studied 100 shows in a 6-month period from October 2015 to May 2016. 100 shows, first season specifically, looked at viewing across 190 countries at the time, and studied the time to completion of the first season. So what would you guess, how long would you guess it takes the typical person to complete the first season? Yes?
Weekend? 1 week.
A week? 2 days? You're very, very close. It's 5 days to completion. That can include gaps. So the median time to completion is 5 days for these 100 shows that we watched, that we studied. The median session for that watching was just over 2 hours per session. People are highly engaged. People watch a lot of TV. People watch a lot of TV. People watch more TV now than they have even 5 years ago. You may know this personally from your own behaviors. I do. Part of it has to do with Netflix itself. The streaming business model is highly amenable to binging, for better or for worse. And because of Netflix, the presence of Netflix and its strategy, we're in what is called commonly the golden age of television. There's an enormous amount of TV being produced, and it's because Netflix and competitors are paying top dollar to stream them globally. So we try to get global rights across the board, wherever possible, to support our global streaming service, and that's new. That's a new strategy in the marketplace. So in 2012, it's arguable that we launched our studio operations then. Here's an article from 2015. This is around the time I started at Netflix. Here we're producing a Brad Pitt movie called War Machine from scratch. So we acquired the rights to do so, and we're building it from scratch. So that's a pure, film studio operation. But as early as 2012, we were branding licensed originals. So pop quiz, what was Netflix's first original?
House of Cards?
Yeah.
It was not House of Cards. They quizzed me on this after I started as well, and I got it wrong. It was Lilyhammer. Lilyhammer with Steve Van Zandt was our first licensed original in 2012, and then we acquired the rights to House of Cards and Orange is the New Black the next year. They're branded as originals in the United States, but that's not true in all countries. I think it was Sony. I think it's Sony that produced House of Cards, that created House of Cards. We acquired the right to brand it as a Netflix original in the United States. And we have since tried to put together global branding rights as well. Every year since then, we've had an increasing number of originals. These are all just original series. Anyone not subscribed to Netflix here? 1, 2, 3, 4, 3. Oh, wow. That's actually a good point. Does anyone not stream Netflix? Let's put it that way. So about 2, 3 people. So even so, I'm sure you're familiar with titles like Stranger Things, which was just enormous last year. And we continue to increase this. This slide was created last year. It's even more this year in 2017. And then the other milestone that I covered in Netflix's history is our global launch in early last year. So there we are.
Just a quick question on global rights, right?
Yeah.
So historically, pretty much all copyrighted material has been kind of divvied out into different national or regional distributors.
Yes, let's put it this way. The demand for, say, film rights was piecemeal because there was no entity to put it all together and do it in a uniform way. So what happens is, or what used to happen, and still does to a degree, is international buyers would come in, and these were businesses, like a Brazilian business would come in, a Brazilian distributor or broadcaster would come in and come to Hollywood and bid on the rights to stream a show or a movie. There just was no player. There didn't used to be any player that could do it globally, that could distribute globally. And there are different kinds of rights as well. There's theatrical rights, there are, you know, DVD and other kinds of rights like that. Streaming itself also didn't exist, you know, as of a decade ago. So yeah, there just was there wasn't even a notion of a single entity buying global rights. So that is changing very rapidly right now. And it's because of Netflix and competitors like Amazon and others who do it this way. It's a very rapidly changing landscape. So a lot of it, you know, a lot of this deal making is just, we're making it up as we go along. And that's what we're here to support, with that kind of decision making. Just to answer your questions in advance, yes, we're streaming in Madagascar. Some of the top series in Madagascar include That 70s Show, Marseille, and Black Sails. Madagascar, the movie, is only about number 11 for films in Madagascar, so it's interesting. We're in Mauritius. We're in some strange places. So global means global, and it's a very fun and very, very challenging to try to support our content acquisition globally. So not only is the product available in all these countries, but our studio is global as well. So Netflix has produced titles like Suburra, which is an Italian thriller film. I think it's a film, yeah. Beasts of No Nation, which you're probably familiar with. Lots of awards, set in a hypothetical West African nation. Club de Cuervos, anyone know that title? Anyone heard of it? It's huge in Mexico. Yeah, hugely popular in Mexico. So that's a Mexican comedy series. Marseille, anyone heard of Marseille? Yeah, so Marseille is our French House of Cards. Narcos, I'm sure you're pretty familiar with. That's based in Colombia with a Brazilian lead actor who speaks Spanish. We have a big anime effort, some originals like Knights of Sidonia, and we're available in Japan. And then another example is the 3%. Anyone heard of that one? No Brazilians? So that's a Brazilian, are you Brazilian?
No.
That's a Brazilian series, dystopian futuristic series. So the studio operations are global as well. I'm going to give you a broad overview of data science across the company, and then I'll dig into my area, which is content. You're probably familiar with personalization and the personalization efforts behind the Netflix product. In 2000, Netflix exposed this star rating feature. I'm sure you're all pretty familiar with that. This is for the DVD service. The idea was if you liked something, you would rate it. And data scientists behind the scenes then were tasked with predicting your ratings, given all of the ratings that were previously submitted. This is a very interesting problem, and it also turns out to be not quite the right problem to solve, for reasons we can get into in a moment. About 7 years later, so that engine was called Cinematch. About 7 years later, Netflix launched a prize, $1 million prize. Anyone familiar with the Netflix prize? Okay. The Netflix Prize was a big deal at the time. They released anonymized, purportedly anonymized, I think Netflix was sued later, ratings for movies from, I have the numbers, which I'm forgetting, it's in there. Ratings from thousands of movies. I think it was 100 million, of order 100 million ratings, if I'm remembering correctly. And the task was to improve upon Cinematch by at least 10% in RMSE. A team consisting of 7 researchers down here called Belcore's Pragmatic Chaos split the prize. So they hit this 10% RMSE improvement mark. Split the $1 million among the 7 people. Netflix then went forth and implemented just 2 of the ideas from the prize and discarded almost everything else. The Netflix Prize is a very interesting study in, I would say, the marginal returns of increased improvement in figures of merit like RMSE. Some of it was useful, some of it was not. RMSE, root mean square error, which is the ordinary least squares regression figure of merit, the most common one. I think the world and Netflix benefited greatly from this. Matrix factorization was popularized through this contest, as was the restricted Boltzmann machine. Those were the 2 ideas that Netflix did adopt. Matrix factorization is highly scalable. Many of the other algorithms that were used in the contest are not. So scalability is one of the huge concerns around the algorithm choice. So today, the product personalization has evolved greatly.
So
yeah.
If you only adopted 2 of the 10 ideas, does that mean that the improvement was not 10%?
Oh, it was. It was some of the algorithms that, so the winning algorithm was actually an ensemble of 500 algorithms. So you have 500 ways of predicting star rating, and then you have another layer where you average them or you gradient boost them, which is what they did, and you get even better performance over any one of them alone. So that was the winning solution. To get 500 working in production is an enormous effort. It is not simple, and many of those 500 are not scalable. They were on the contest data, but at scale behind the Netflix product, it was not the case. So matrix factorization is one of the more scalable, interpretable, simple, and pretty accurate solutions. So it turns out to be worthwhile maybe to back off a little bit on accuracy in favor of scalability. And that certainly was the case for Netflix. Today, a lot of those elements are in use today, although the recommendations have evolved even since then. So the position of each of these titles in a row, that comes from an algorithm, here and here, 2 different ones. The actual rows that appear here and the order that they appear, that's another algorithm. That's another model. The billboard, we call this the billboard. The billboard title and art, that's another algorithm, another model. And then if you go to search, which some of you I know do, not all of you, the search is based on another algorithm. The page is constructed from an ensemble of algorithms. So this is like data science in action, like almost 100%. And you can read more about it there. Another big area besides personalization and product science is experimentation. The idea behind experimentation or A/B testing is to try to avoid going on individuals' opinions, particularly the highest paid person in the room, in favor of actually rolling out ideas to the consumer in different groups and measuring directly long-term engagement and other metrics that are core to the business. That's the crux of A/B testing. And Netflix has been A/B testing for quite a while. We have a huge architecture dedicated to rolling out N different versions of the product to different cohorts of people. That's A/B testing. And then summarizing the results on some of our key metrics. Yes?
So the scale problem, I'd like to go back to that. Maybe it fits in some way here.
Yeah.
I'd like to understand, given that some of this doesn't have to be in real time, right?
Okay, yeah, right.
So the complexity, when it comes to complexity, is it the competition complexity, or is it memory complexity, or is it the, when we say scale?
Yeah.
Or is it the storage? What's probably the most important factor?
It's the time complexity, you know, and you're right, you can score not in real time, but every day and score them. It's called batch scoring. Certainly doable, and we do that. You need to be able to compute it in a day to do daily scores. It is sometimes the scoring can be longer than a day. So even batch scoring is not a blanket solution as far as scalability goes. So yes, not everything needs to be real time. Some things do, most or many things don't. And we take advantage of batch scoring wherever possible. Yeah. Okay. So this is our a diagram of our A/B testing architecture. Here's an example of an A cell and a B cell. So what's the difference between these two? What about it?
The posters.
That's right, just the posters, the cover art. So Breaking Bad is in position 1 in Watch It Again. Breaking Bad is in position 1 in Watch It Again. All the titles are the same. The only thing different, I think, is the cover art. Yeah, that's even true down here. Here's Mulan. I think that's Mulan, Hercules. So this is an example of one of the A/B tests that we have performed, optimizing the cover art or box art. And it turns out that some art is better than others in terms of getting people to engage. And not just engage immediately, but also in the long term. So there's some amazing results that come out of A/B testing.
Do you do interactions to find out whether certain cover art works better with certain types of people?
Yeah, interaction is tough with certain kinds of people. I did not execute that test, so I actually couldn't tell you in detail how we segmented the population. I think we try to keep these as simple as possible, each one, but it results in one tiny change here and another tiny change over here, and they do ultimately interact. So these build up over time. We have many, many A/B tests per year. Many of you are in a cell right now being experimented on. You can disable that, by the way, in your profile. I don't see why you would, but you can. So the aggregate effect of many, many tests per year has resulted in the product that you see today. And I remember this and even previous iterations. In my opinion, and I'm certainly biased, I think Netflix has the best SVOD streaming UI of any of its competitors, including Hulu, Amazon. It's a very clean experience. It's beautiful. It's not clunky. A lot of that rebuffering that we all experienced in 2009 doesn't seem to be happening anymore. That's not magic. So it really works. And we have a huge team dedicated to looking at these experiments. Yes?
So I'm actually wondering how you came up with the fact that on your UI you have very few, because that's actually the thing I hate the most about Netflix. I like everything else pretty much, but I just don't like having to scroll forever to find other potential movies.
Yeah.
So I'm wondering how, when you're doing data science, how you can actually factor that in.
Yeah.
For example, for the people, because it's hard to, I guess, test that.
Oh, we test it. We certainly do. If you go to this paper, they'll talk about catalog size and a metric that we use called effective catalog size. You know, we have a catalog of tens of thousands of shows for you in the US right now. It's way too many. for you to discover and like leaf through, right? In any traditional sense. Discovery, so the problem is one of discovery. So what we do is we try to present the smallest number of high value titles to you at any given time. That is the attempt we're making. It is certainly imperfect for reasons that you're describing, but the alternatives are things like search. If you had to search for the titles that you were looking for, which you can go click out of this and go into search and search for the title. 9 times out of 10, roughly speaking, you will not find that your title is available on Netflix. So that is a worse problem to us and to you than just presenting what we think is good for you now. It's a tough problem. And I do think there's a lot of areas of improvement. But where it's at today is certainly better than a lot of the alternatives. And it's a very interesting paper, high-level paper.
So another question is, as a data scientist, you can probably say something about people's probability of clicking through to a particular film based on their characteristics.
That's right. In fact, that's how these are
On the
selected.
business side, right, there are different costs associated with different content. So, the one that they're most likely to click through to may not be the one that is most cost effective to show them based on the contracts that you have and so forth. How does the data scientist incorporate the kind of costs and benefits of different actions that consumers might take?
Well, we have, on the product side, we have essentially no overhead in streaming an additional title. There's obviously the cost of acquiring the rights to stream the title, but we separate out the two currently. So presenting it to you, it's an even playing field. Roughly speaking, it's a totally even playing field. We want our key metrics to be maximized. And our key metrics, you can imagine what they are. They have to do with long-term revenues, right? And so we have elements of acquisition and retention and month-to-month engagement. So I think we generally ignore the cost side. We use cost benefit analyses in the deal making itself, but once the deal is executed, the product is free to recommend whatever it wants. That's how we frame it right now. Another big area of data science research is streaming, the streaming experience, quality of experience. Netflix, you may know or may not know, stages its content at ISPs, physically at ISP offices to get the content closer to the consumers. This reduces latency hugely. And so we have a global effort to do this and an open source product, software product called OpenConnect. There's lots of write-ups on this. There's a lot of streaming optimization to do between the time we get digital assets from our vendors, from our studio partners that we acquire licenses to stream from, or from our originals, all the way to the consumption by Netflix subscribers. There's a lot of areas to optimize in between there. We also have a big marketing science team where we do traditional and online programmatic ad impression buying. I won't get into that very much at all. And as a quick interlude, this was an animation. Before I get into content, which is my area, I'll tell you a little bit about the technologies. Do you study big data technologies, at least to any degree?
Very, very minimally. We're going to have at the end of this week, someone's going to talk about data architecture.
Cool. Yeah, well, this touches on that. Netflix's strategy in big data architecture includes full cloud adoption. So Netflix migrated fully to the Amazon Web Services cloud a couple years ago. And the vast majority of our services are up in the cloud now. And we use a lot of, we're also big on open source technologies that I'm sure you'll touch on. These include S3, which is Amazon's big data storage service. And we use heavily technologies like Hive. This is where the individual log data comes in over here through a Kafka queue, and it has to be parsed and stored. And then there's an access layer, which is sort of over there on the right and the bottom. We use technologies heavily like Hive, Presto, which run on Hadoop and S3, Python, Spark, Redshift. We're evaluating Redshift as well.
General question. You mentioned you moved to Amazon Cloud, but
Yeah.
you also said you host your data close to the ISP.
Yeah, that's caching. You can think of that as caching. Yeah,
Okay.
but our core services all live in AWS. Yeah, you could just think of that as local caching. Yeah.
Is dependency on AWS a concern for Netflix?
It's certainly something that we have thought deeply about, and we've come to the conclusion that everybody's interests are appropriately aligned. Does that answer your question? Yeah. Yes.
As you increase subscriptions across the board, is there something about where like, you want like an optimal amount of usage from each subscriber, so that if someone's watching too much, your content delivery networks are going to get. So like, how do you balance that against recommending so many?
Well, short answer is the recommendation is separate from the consumption metric. I mean, recommenders have their own consumption metric, but it's my job to look at long-term consumption and evaluate the content. And that I'm going to get into that directly just in a moment. For analytics, we make heavy use of R, Python, a little bit of Spark, some of the newer modeling packages like H2O, which is great, TensorFlow out of Google, and Keras, which is a really nice layer on TensorFlow. We even make use of Amazon, of crowdsourcing with Mechanical Turk a little bit, where appropriate. So we're big Python users and big R users as well. Are you using R in this class? SAS? What was that? What language was that?
We're just using Big ML.
Okay.
And Excel.
Oh, cool. Looked like R. So we have a lot of different kinds of machine learning algorithms in production, both consumer-facing and internal facing products. We're using logistic regression, which I saw you were using. We use regularized logistic regression pretty heavily. Linear regression we use heavily as well. And elastic nets are a kind of regularization technique for logistic and linear regression. We make a lot of use of gradient boosted decision trees. Gradient boosting is a wonderful, wonderful method, very general, very intuitive and analytically well motivated, scalable. Gradient boosting is amazing. We use matrix factorization, as I already mentioned. SVD is matrix factorization, that's singular value decomposition. But there are lots of other flavors of matrix factorization, including factorization machines, et cetera, et cetera, et cetera. This is latent Dirichlet allocation, which is a big technique in natural language processing. So now I'm going to talk about my area of data science at Netflix, which is content or content acquisition science. So to answer, I'm sure, what is a burning question for everyone, can artificial intelligence create content? Anyone familiar with Benjamin.wtf? That's a website. You can go there. You can go there now. Benjamin.wtf is an automatic screenwriter based on artificial intelligence. The architecture is an LSTM-RNN, long short-term memory, recurrent neural network, conceived by two people. So this is a deep learning artificial intelligence that's trained on screenplays and generates new screenplays. Thomas Middleditch performed in one such screenplay. Thomas Middleditch of HBO Silicon Valley fame. Here's a snippet. He is standing in the stars and sitting on the floor. He takes a seat on the counter and pulls the camera over to his back. He stares at it. He is on the phone. He cuts the shotgun from the edge of the room and puts it in his mouth. He sees a black hole in the floor leading to the man on the roof. So this is a screenplay. This is on YouTube, and I think they link out to it on the website. So you may see where I'm going with this, which is that we do not do this. It's art. There's a difference between art and what is quantifiable. And so we have no efforts along these lines. What we do is we support creatives. We support business analysts, MBAs, you know. We support buyers, people who negotiate with the studios, with tools, models, and give them the best estimates of things that we can estimate. Not everything is quantifiable. So we give people especially creatives, the freedom to do what they want to do and know how to do. And if they want the numbers, they're there. And we provide the models and the tools to help them do their jobs better. That's what we do.
I guess you have to be asked about the anecdote related to the origins of House of Cards.
Yeah.
Which an urban legend is that
Exactly.
data scientists
Created
the show and its casting from user preferences.
That is a common misconception, and I don't know who to attribute it to. I'm sure it's attributable to somebody. No, Kevin Spacey and what's his name, David Fincher, came to Netflix with the show. And we acquired the right to stream it. That's what we did. Now, when people do this, when people come to Netflix with a show, we do a lot of analytics, obviously. We try to predict its performance and its value. We always do that. We don't create content using artificial intelligence. So I would call that a misconception. So a huge aspect of this is value attribution, which gets at your question a little bit. How do you attribute dollar value to content at Netflix? So let's talk about very quickly how linear TV might do it. So this is ad-based linear TV. Their business models are centered on advertiser revenues. So the value of a show on linear television that is ad-supported comes from the number of eyeballs on that show and therefore on the ads in between. So that's relatively easy to attribute value, and you need estimates of the number of eyeballs from companies like Nielsen to do this. So that's Nielsen's business model. Netflix is not ad-based, and so it's tough. It's a lot harder, actually. So let's think a little bit about another service like Amazon or iTunes. iTunes and Amazon have TVOD, which is transactional video on demand, pay-per-view. So you can go on to iTunes and purchase a movie. You can go on to Amazon and purchase an episode or a season. That's TVOD. The value attribution problem there is really easy, at least in my mind. A person pays specifically to watch a given episode or movie or season. And you ascribe that dollar value to that movie, episode, or season. Netflix's business model, like Spotify, is monthly. So I can, watch a movie a day on Netflix for a month. And another subscriber can watch one movie, even 0 movies, in a month. And we both pay the same thing. It is possible to attribute dollar value in this case, but the math is just a little harder. So that's a rough sketch of our value attribution problem. I'm curious, how do you think you would write down value for Netflix, for a Netflix-like business model? What are some of the issues around it too? Yes.
You try to build a model to predict the likeliness that they continue subscribing to your account. You can try to fit that maybe their habits into that model.
Yeah, I would call that a lifetime value model, customer lifetime value model. That's a great way to do it. Yes.
Part of it may be like what type of time horizon you're thinking about. So, like if current subscribers are helping you acquire new subscribers down the line, kind of like maybe they're subsidizing the current ones. to some
Right.
extent.
So maybe there's a notion of growth versus revenue phases of the business, like Amazon. In a growth phase, you're not happy with 10% penetration of a market. You're not happy even with 50% penetration of a market. So what do you do? How do you get new people in the door? The lifetime value problem has a lot of aspects. There's getting people in the door, which is acquisition. There's keeping them, which is retention. And there's a sweet spot of churn that ensures growth by some target date and long-term lifetime value. Yes?
Whether people share or email that movie to their friends.
Yeah, that's a good one. Buzzworthiness, is that on here? Yeah, binge-worthiness is on here. Cult appreciation. Stranger Things may be along these lines. Yeah. Anyone else? Yes?
To your point about, I guess, the later part of the life cycle, looking at shows that may be attributed to users that have low churn.
Right. So there's a notion of different likelihood of canceling for different subscribers. So a lifetime value model should be personalized to customers. I agree. What if you have a catalog of 10,000 movies and series, right? I have that now. Now I want to evaluate whether I should take on one more title. What about issues around that?
Well, it's going to cannibalize somehow the views from the other titles that you already have whenever you want.
Right, so maybe it'll take away hours from another title, reducing its value to us. Maybe it won't though. Maybe it'll add to the total engagement for a large number of subscribers. Or maybe it's something in between the two, right, on a continuum. Yes?
So on that topic, you mentioned being able to kind of score incoming titles, predicting how well they do. I'm just curious how do you guys achieve that, you know, outside of like the eyeball test and like critics and stuff? How do you do that in like a data-driven way?
Yes, I'm going to get to that in one slide. That's the licensed content value prediction problem, and we do it. We go beyond, you know, sticking your finger in the air or any qualitative stuff. So I'll touch on that in one moment. But assuming we've solved this notion of value, Netflix makes heavy use of a quantity that we call efficiency, which is the value extracted from a piece of content relative to its cost. Efficiency of 1. If a piece of content gives you an efficiency of 1, you have some notion of break-even return on investment. If the efficiency is less than 1, then maybe it's underperforming relative to its cost and therefore its original forecasted value. If you have efficiency greater than 1, then that's a great situation. You have some notion of return on investment for that title. So ultimately, value is one piece, cost is another, and they're baked together into a return on investment type analysis. So let's talk about a little bit how we predict the value and consumption of content, which is the meat of my job. This problem has a lot of aspects from a data science perspective. The simplest one, which is so simple you might ignore it, is understanding what titles are available. This is harder than it sounds. What titles, you know, what's the output of all of Hollywood in 2017? And how do you programmatically pull that into your data warehouse? What about for non-Hollywood markets, like Bollywood, like South Korea? These countries have very robust and very insular, relatively insular, entertainment production markets. So how do you do it there as well? So title sourcing is a tough problem, and that's the first aspect of the value prediction problem. If you have the titles, then you need to mine signals that are indicative of demand or the value to Netflix. Demand, let's call it consumption. So, you know, the simplest thing I can think of is box office, theater ticket sales for movies. So if we're thinking about acquiring the rights to stream an Avengers movie, we'll look at the box office. For series, you know, I showed you Nielsen. We could, in principle, use Nielsen. There are other metrics that exist out there that are predictive of consumption. So this data mining part is another big aspect of the value prediction problem. We build models to predict this value notion or consumption using those models that I told you about, gradient boosting, et cetera.
So
yes.
Quick question. Presumably, if you were to purchase the material earlier in the value chain, you could, you know, get it for potentially less, right? And so, but you have less information, so you would make a less accurate prediction. Is that one of the choice variables?
Absolutely.
So, you know, you have to, if you believe you have a better valuation model than the seller, then you would probably try to swoop down earlier and acquire it.
Right.
If you think that
or you could monetize it better than the seller thinks you can, or whatever. Yeah, exactly. Or than your competitors can.
So you actually put a value on sort of the uncertainty reduction that you get from waiting to acquire the content after, say, the box office has been revealed?
Yeah. So the analog is, you know, risk reward. That's the risk piece. I would chalk that down to risk. The less information you have, the more variance you have in your modeling, which is risk. The analog is portfolio, you know, modern portfolio theory and portfolio analysis, which is that if you have a higher appetite for risk, you have a higher potential for return. And the answer is yes, you can get things cheaper earlier, and the uncertainty is significantly greater at earlier stages. And I'm going to get into that. So I'm talking right here about licensed title acquisition. These are things that people have generally already seen. Then there's originals valuation, which I'm going to touch on immediately after this. Once we do this, you know, there may be things that are unquantifiable, or that at least the data science team has not fully quantified. So these are adjustments, premiums and discounts that are not modeled directly in this previous step. And we have large teams of analysts, financial analysts, business analysts, buyers, and creators who give us insights on what additional adjustments they might want to make to titles. It's tough because some of it is judgment that is not quantifiable. We have a big custom machine learning framework that enables this kind of work. And this is a picture of it, which I won't get into. But this is a pretty generic sort of machine learning in production framework. And now we'll talk about the problem not for licensed content, but for originals. For originals, we're much earlier, usually much earlier in the production life cycle for any given show or movie. So there's less data. We have no box office. We have no reviews. And it goes even beyond that. Studio productions, any given title in the pipeline undergoes quite a lot of changes in its lifetime. So I'm going to give you an example, a real example of The Revenant. The Revenant is a book by Michael Punk that was optioned by a studio in 2001, and I actually don't know what studio optioned it in 2001. The Revenant is set in 1870, and it's about a black scout who is mauled by a bear and then left for dead by the white trappers he was leading. I did not know that. And Samuel L. Jackson was attached to the leading role at time of option as the main black scout. 6 years later, it appears on the blacklist. You can go to this website. This is like a repository for movies that haven't been, aren't being produced yet and are in a kind of holding pattern. And then it was changed fundamentally, and Christian Bale was attached to the leading role at that time. In 2011, it finally got funding at $60 million with Leonardo DiCaprio attached to it. And then in 2014, it was filmed at a cost substantially greater than that. But then in 2016, it won awards for Best Director and Actor. So they certainly got returns despite their gross underestimate of the production costs. This is just a sketch. I mean, there's so much more that changes behind the scene. There's the script itself. There's the pitch itself. There's, you know, this is a fundamental change that happened very, very early, and one wonders how that changes the ultimate value of something like The Revenant in the marketplace. Talent changes, scripts, productions, showrunners, locations, budgets themselves. There's so many dimensions that you have to keep up with. So prediction in this kind of environment is a big challenge, and it's fun. It's a fun challenge. One way to handle this is to use comps. Comps are common across industries. If you've ever bought a house or an apartment, your apartment was valued based on comps. If you go on Zillow, you can look at comps. We have the same notion for movies and series. Maybe House of Cards is like West Wing meets Breaking Bad or something like that. Maybe. But importantly, these are titles that Netflix has streamed in the past. So these are titles for which we have actual user viewing data. So we look at titles that we streamed that we think have elements that are similar to the production under analysis. And then we can look at, for those members that watch those, all of the other titles that they watch. So it's like Twister, which is of course the world's biggest blockbuster movie about tornadoes, meets Shark Week. And we have a tool that does comps. If you put those two titles in it, this is the movie you get out. It's pretty amazing, actually. It's pretty incredible. This is a whole, similarity measurement is a whole subfield of data science, and doing it on big data is very challenging and hard. This doesn't happen to be the biggest data problem, but Google solves it, for example, by other advanced means. Yes?
So correct me if my assumption's wrong, but I think Netflix has had a highly successful rate of originals.
Yeah.
Right? I don't think you have huge flops like a lot of the studios have had, especially in the last couple of decades. So considering they've been doing this 100 years, some of the big guys, and they use similar methods, why are you outperforming them? Or do you just have more data now that you've gone digital, or why are you doing better?
I mean, there's lots of aspects of the answer to that. One is we do actually hire the best producers. You know, we do target the best creatives in the industry. To do so, you have to pay top dollar, and we do bid top dollar for content. That's what's driving up prices. And you're looking at the end result of that. As far as, you know, what kind of data science are the other studios doing? I don't know. But I will tell you, they don't have, as Greg mentioned, they don't have the individually addressable data that Netflix has. Okay? So they have to purchase their viewing data from Nielsen for series. For movies, what is it? It's box office receipts. We have viewing to the millisecond on every single profile in every single account. So that means that we can see when people drop off, right? We can see if people pick it back up where they dropped off. Maybe they dropped off in the first 10 minutes of a movie. That's a level of